All right, everyone. Hello and good evening. I am so excited to be here tonight with all of you. My name is Tanya Garcia, and on behalf of the Conejo Open Space Foundation, I want to welcome you to tonight's presentation, our very first webinar of the 2022 speaker series titled Conejo Valley's Changing Climate, Current Threats and Paths Forward. We are so thrilled that you're all joining us tonight for this exciting and very important presentation. As a young kid, I took every opportunity to get outside. I don't know about all of you. I'd play in the mud, I'd chase butterflies, I'd go exploring. I learned to appreciate the fresh air, the dirt on my skin, the color of the grass, and that great blue sky. I loved every second of it. And now as an adult, I do remember I am still that kid who enjoys their outdoor spaces. And I am so honored to be part of an organization that embraces that, the Conejo Open Space Foundation. I'm sure many of you are familiar with our work. However, some of you may be new to our organization. As an all-volunteer nonprofit group, the Conejo Open Space Foundation focuses on educating our local community, the Conejo Valley, about our outdoor spaces. We also focus on raising funds to support programs and initiatives related to keeping those areas protected and accessible to all. Each year, we host this wonderful speaker series to help bring interesting and informative information to all of you on topics related to our beautiful valley. Thank you to those of you who participated in our very recent survey regarding identifying topics that are important to you. We greatly appreciate the input, and it will be put to very good use as that feedback will help us design our activities such as today's webinar. Another example of one of the many ways that we make a difference through the foundation, we are very excited to share this with you. Exciting news that recently we contributed to the National Wildlife Foundation's Wildlife Corridor Bridge that will cross the 101 at Liberty Canyon. This bridge will enhance safety for our wildlife that patrol our Conejo Valley, all our open spaces, enhancing the entire region's natural areas, not to mention further protecting us humans as well. As the Foundation's Vice President this year, I'd like to take this opportunity to especially thank the many, many donors joining us tonight. Whether you contributed because of this event or are an annual donor, your contributions are making a major impact in the work that we do. We thank you for making a difference in your community. Please continue to keep the Conejo Valley open space in your philanthropic plans and reach out to us at any time. And now it's time to move on to our wonderful program tonight. I am just so happy to have our guest speaker for tonight, ecologist and conservation scientist, Dr. Sean Anderson. As the chair of the Environmental Science and Resource Management Program at California State University, Channel Islands, Dr. Anderson will discuss with us the threats posed to the Conejo Valley by climate change and how best we can respond to them. Describing Ventura County as the epicenter of climate change impact in the lower 48 states, Dr. Anderson will also share new solutions to building more sustainable and resilient communities. I've personally had the opportunity to work with Dr. Anderson in a past life, and his insight, knowledge, and research are unparalleled. And he has an addictive, wonderful energy. But before we jump into the presentation, a few housekeeping items for all of us on the webinar. Note that all attendees are muted for the duration of the presentation. The presentation will be roughly about 45 minutes with an opportunity for questions afterwards. We do welcome your questions submitted at any time during the presentation. Please use the Q&A tool at the bottom of your screen. My fellow board member, Marcella Kettlehut, is with us tonight and will be moderating the Q&A for all of us. We will also be recording this event, so you can either rewatch or share with your friends. Please note it does take us about a week to get that up on our website, but we will always let you know when that happens. And with all that, and without further ado, Dr. Anderson, would you take it away?
Oh, thank you. I'm bummed. Now. I'm nervous. I'm supposed to be both interesting and informative. It's like, oh my God, there's so much pressure here. Let me share my screen and we'll get going here. Okay, hopefully everybody can see that. Let me just minimize this window right here a little bit. Okay, perfect. So thanks everybody for showing up tonight on this Ash Wednesday evening. And on this Ash Wednesday evening, we're starting with a picture of a bunch of ash in the air. This is during the Woolsey fire. This is PCH looking towards Ventura County from Los Angeles as people are evacuating. Fire, we'll talk about fire in a bit, but fire is but one example of this new world in which we live. And so it's part of the story, but there's other things going on as well. Oops, what's going on here? Let's see if I can make that guy go. Okay, good. So a couple different terms. A lot of times when we talk about climate change, there's all types of terminology and things, and sometimes it can be confusing as to who's talking about what. What's the what are we talking about? Sometimes we hear the term climate change. Sometimes we increasingly hear the term climate crisis, sometimes global warming. A lot of these are interchangeable. The term that I prefer to use, though, is global weirding, because I think that best describes what's going on now. And as we continue to go on to future decades, things are going to get just more weirder. And I think that's the right frame of reference as we go on and start to talk about what's going on and what's going on here in our homes and in the wider region. That said, let's start off with making sure we're all on the same page here. So this is an animation. This is about a 2-minute animation. We're looking here on the left and the right. We're looking at the concentration of carbon dioxide in the atmosphere. These are all, this first part here is direct measurements, where we humans have taken a little sample and checked it out. And so what we're seeing right now as we move through time, that's the real time there on the left side of the screen across the globe in the atmosphere. And on the right, we're just tracking this. We can see the breathing of the earth, in and out as we go through the seasons, and we're progressing. Now, we started in 1979, now we're up to 96, and we're seeing this number go up higher and higher. Now we're about 2000s, we're at about 370 parts per million. And it's getting higher and higher. This is the reality. This is the fact. This is what we've predicted, and we've seen the increases follow our predictions. This CO2 is coming from our actions, our industrial activities as a species. So that's burning fossil fuels, that's clearing forests, all the collective activities we do. So now we're about 5 years or so ago, and we're getting close to roughly 400 parts per million. And now we're going to pause. So now let's start to look back at our historic record. So now this is still stuff that we directly measured. So now we're back to the 70s. You can see how much higher that the level of atmospheric CO2 is. Let's go back even farther. Now we're starting to use indirect measures where we're looking at ice cores and things of that nature. And so now we're going thousands of years into the past, and we're going farther and farther. Let's go even farther. So now we're going to go many thousands of years. Again, we are right now at the top of that right-hand curve. This is all of human history. This is where all of our plants and animals have evolved. This is all where our crops have evolved. This is this low level. It went up and went down, but it's never been this high for over 800,000 years. So that's the situation that we are in right now. So some people say, well, it goes up and down. No, we are into new territory here. Certainly new territory ever since we have been a species on this planet. So this is unprecedented for us as humans. And so the question we're faced with is not, is this thing happening or not? We left that a long time ago. We are now faced with the question of, will any semblance of our old world remain once the dust settles from all this stuff that's going on right now? So we really are talking about survival here in a very real sense for us and the rest of the planet. It's also important to say, before we get going too far into this, that how we respond has been constrained by our previous choices and our previous actions. So we have the world that we have right now in 2022. We still have lots of agency. We can still absolutely have huge effects on how this story plays out. But we are where we are because we failed to actively engage with this problem robustly over the past many decades. And so we're Indiana Jones, right? Running from the giant. That's for my son. My son loves Indiana Jones. We're not going to sit there and debate whether there's a big giant ball rolling towards us. We need to start running and get out of the way right now. And so in this new world that we are in, we're not going into this world. We're already here. It's just changing. It's just going to be changing even more intensely as we go in the future. But we're already in a changed place. In this new globally weirded world, we're going to see our trees and our fleas and our birds and our bees. Things are changing. In some cases, things are likely to become a little more abundant or a little more numerous. In some cases, things are likely to become less abundant, less numerous. Overall, the diversity of the wonderful fabric of this miracle of a planet that we live on is going to be more frayed. We're going to be less verdant. We're going to be less diverse, and so things are changing. So let's talk about what some of these what some of this looks like. Most of our modern systems, our modern transportation systems, whatever you want to pick, really grew up in the 1950s, in the immediate post-World War II era. And the question is, will we recognize that post-1950s world by the time we get to 2050 or 2150? What is happening with climate change is, first and foremost, we're seeing direct impacts and changing of our ecosystems. That's the most obvious one. That's the one that probably most of us sort of see. But there's other things going on as well that we haven't really fully gripped yet. And while we've seen lots of examples of number one, we haven't seen quite as many examples of number 2 and 3. Number 2 would be black swans and gray rhinos. We'll talk about what that is in a second. And then the biggest worry are really major shocks that function as destabilizing efforts that have tremendous ramifications on our society overall. So number one, this is weird when I'm just talking. Normally it's like, you guys interrupt me and ask questions, but I will attempt again to be interesting and informative. So first and foremost, let's take this example of direct impacts of changed ecosystems. We are now seeing clear examples of misalignments of how things change over the years. So the phenology, so the timing when plants put out their flowers, the timing when the pollinators come to those flowers, and so on and so forth. And that misalignment is causing problems. Sometimes when that misalignment is so intense that maybe when the bee shows up to get that pollen, there's no pollen left, right? Or there's no food for that butterfly to eat, or whatever our favorite critter is. We typically talk about the habitat of the bear, the habitat of the coyote, the habitat of the creosote bush, whatever it is. But increasingly, things are starting to become so out of whack, it's unclear if say our home, our backyard, our open spaces here in the Conejo Valley, if that really truly is habitat anymore for that critter. The conditions might have changed so much, the water availability, etc. We're also broadly seeing things becoming much more hospitable to weedy things. So things that are, kind of in the cracks in the sidewalk, and in the sort of aggressive growers of the plants, and the crows and the ravens and those kind of guys coming in. It's becoming a much better world for those types of critters. And then next, we also have seen broadly writ, because of all these above things I've just mentioned, increasing fragmentation of our ecosystem. So breaking what was a contiguous area into a bunch of chunks of smaller areas. And concomitant with that, we're also starting to see extinctions now of critters. And as we go on to future decades, that's going to become much more intense and much more profound. Here's one quick example of that, and then we'll go on, talk about some other things. But this is an experiment that we worked on for several years. This is the plant on the right is a Dudleya, a small succulent. We have lots of Dudleya around our parts of the world. They're a really cool plant. They're a very popular plant for people to keep in cultivation. When the Springs Fire, the 2013 Springs Fire happened, that started on the Conejo grade, went through CSUCI and sort of the edge of the Oxnard Plain, hit the Pacific Ocean came back up into Thousand Oaks from the ocean, we burned up a huge amount, essentially all of the habitat of this species. This species was only located now, historically was all over the place, into downtown Los Angeles, et cetera. But because of development, et cetera, its distribution got reduced. When the Springs fire came along, there were several thousands of individuals left in different pockets around the Conejo Valley. Essentially 100% of the habitat of this critter burnt up. Afterwards, we only found 3 remnant populations of this individual on public lands. And we went from many, many thousands of individuals to a few hundred of individuals. And when we talk about, and these are kinds of plants that can reproduce asexually, so can clone themselves. We don't have all the data yet, but there might have been only a handful of genetic strains. So we might have gone from many thousands of individuals to a few hundreds, but genetically, maybe only 3, 4, 5, 6 unique genotypes. That's a huge challenge. So we're working on planting these little models here that are little natural places where the seeds can land and grow, but it's hugely problematic. Several of our restoration sites have now been robbed by plant poachers because these plants are so valuable. So Dudley, as a poster child for the danger that critters, organisms can get into in this climate changed world. Okay, next, let's talk about black swans and gray rhinos. Black swans, a very popular thing that everybody discovered the idea after the 2008 financial crisis. But and so typically these things are spoken about in a economic context. But the idea of a black swan is something that just came out of blue. You know, how rare is it to see a black swan? Mostly we see white swans, and oh my God, it's super rare. And we couldn't have predicted a swan would have shown up here, right? Not our fault, in other words. People have used that analogy, but perhaps a better analogy would be what people are now talking about as a gray rhino. So a gray rhino. So a gray rhino, if we're out, say, camping in the savannas or wherever we are in Africa, there are rhinoceros out there. And we know they're out there, but we typically pretend that they're not here. They're not here. They're not a big deal. We know that if we ticked off a rhino, he or she could come, barreling through our camp and cause a lot of problems, but we choose to ignore it. So climate change, sometimes people say, oh, it's a black swan. We couldn't predict what's happening. It's much more accurate to refer to it as a gray rhino, something that we know is coming down the street, whether we're preparing for it or not. And so here's an example of gray rhinos right now. So something that's, again, indirect but predictable. We've not put a price on carbon in our society, right? So we treat pollution as if it's free. You just buy that oil, do that whatever, buy that plastic packaging, and whatever, the pollution will take care of itself. So because we don't have a price on carbon, that has led, amongst other things, to a lot of pandemic buying, right? So one of the reasons, we're all stuck home, we have been all stuck home during COVID, but in addition to just being stuck home, hey, we can buy stuff and it's relatively cheap. We're not paying the full price. And so that's led to many of us buying tons of stuff. And that's strained the supply chain. That strained supply chain has led to vessels backing up in the port of Los Angeles, which takes in about 60% of all the cargo, the freight in the US. It goes to that one port. Things are backed up. So normally over here in San Pedro, where the boats would go in, the ships would go in, there's a little parking lot. The parking lot's been filled for over a year, well over a year. And so when ships can't get there, they kind of scooch around. And one of the things that happened a few months ago was one of those ships dragged an anchor and ripped open a pipeline, and we got the Huntington Beach oil spill. So that's a clear gray rhino, right? That is, we couldn't have predicted exactly where that oil spill was going to happen, but this notion of disrupted supply chains, et cetera, was absolutely something that could easily have been predicted if people were paying attention, and how sensitive we were to that. Another quick example is another oil spill that happened just about a month ago in Peru. The proximate cause was the Tonga tsunami. That tsunami came across the Pacific Basin, whacked this oil tank farm. But again, because of the pandemic and because of strained supplies, we weren't ready for that wave when it came in. As a consequence, we had a big dump of oil. So gray rhinos are another important thing. And the third theme here is this notion of destabilizing social disruptions. So we could talk about Hurricane Katrina. On the left, you see, I'll give you guys a 2-second guess I know you guys can't talk to me. It's as if we're interacting, but we're not really. This is taken in the immediate wake of Hurricane Katrina striking the city of New Orleans. It's an aerial shot. It's of a overpass, and you can see there's a bunch of people sitting here. Any guesses as to what? I'll let you guys guess in your head what you think what those people might be doing there, or who those people are.
Sean, might that be folks there to help clean up?
Ooh, great guess, but no. If we look a little bit closer, we'll see these vans here look all kind of official, and there's some official guys standing around here. And if we were to zoom in, we'd see they all have shotguns. This is the jail. This is the New Orleans jail, which was subtidal at this point, underwater. So they had to rip everybody out of jail and put them up on this overpass because they all would have drowned. And so this is 95-degree weather, 95% humidity. This is going on day 3. Not a lot of water, no shade. These are stressful situations, right? So Hurricane Katrina wasn't quote unquote caused by climate change, but the research now pretty clearly shows the intensity and the strength were likely increased due to climate change. We can also talk about the Syrian civil war. We're having a horrible crisis now in the Ukraine. But as of a couple of years ago, the Syrian crisis was number 1. That was caused by climate change, very clearly. So climate change induced drought, which led to crop failures, which led to a lot of social upheaval and protests of the government, which eventually would boil up into the Syrian civil war, directly sparked by a climate change stressor. So this notion of destabilizing social upheaval things is very real, and we're going to see more and more of this as we go forward. Okay, so that's the context. Oh my God, I've been talking so long. I'm being professor mode. Let's talk about Conejo Valley. So what's going on here in our globally weirded world? So we're seeing changed temperatures, we're seeing changed rainfall, and we're seeing changed air movement here locally. So let's look at in Ventura County, as crazy as it sounds, Ventura County is ground zero for all of the lower 48 states. There depends on some metrics, 1 or 2 things. Somebody might be a little bit worse here or there, but when we take all of the factors related to climate change together, Ventura County is either, if not the most changed county in the U.S., it's tied for the most changed county in the U.S. It's pretty crazy. So let's take a look. Let's first look at temperature here. Okay, let's take a look at California. This is the broad pattern overall in terms of California from, for about 125 years or so ago to now. And so again, some years it's warmer, some years it's colder, right? And that's just natural variation. But the overall, the big picture, the left side of the screen to the right side of the screen, we see if things are getting warmer, getting warmer, getting warmer, getting warmer. And this is what this looks like mapped out across the whole US. The hotter the color here, the warmer the temperatures have gotten. The cooler, the paler the color, either temperatures have not changed much over the last 120 odd years, 25 odd years, or they might have actually decreased slightly, just slightly. And so here you go. So there are some clear hotspots. Upper Midwest, there's a Minnesota kind of area. There's some problem areas. Around Utah, there's some problem areas. But also check out Ventura, right? We're deep purple over there, much more so than anywhere else in the state of California. That's not to say, of course, it's hotter on any one day, maybe in the Mojave Desert. But as far as our change compared to our baseline, compared to what we were, we've changed the most. Let's look a little more intensely. So here we go. So here's a little blow up of that. And on the graph here to the right, this is the same data. The graph here on the right, just in a more graphical fashion, the orange line is the overall change, the average change in Fahrenheit of the state of California, and here's Ventura County. So we are changing more rapidly than even our state, which is changing more than many other states. And then here's what the Conejo Valley looks like. So this is the Conejo Valley. The modeled temperatures from 2050 relative to what our conditions were at the turn of the century in 2000. And we're getting warmer and warmer. Let's look a little more in depth at that. So here we go. So this is the shift of summer highs. What am I showing you here? Let's look at this. First, let's look up here. This is the current condition, or it was done a couple years ago. So very recent, I'll say. So this is the bars here are the low and the high, and that's the current condition. And then the rainbowy color band is what the projected conditions will be. And so here are the biggest changed cities of 100,000 people or more in in the U.S. And so here we go. So we have actually, I take it back. It's some of them are smaller than 100,000. So we see this upper Midwest. Some of those folks are changing a lot. And then here's some of our other local areas around us: Lompoc, Torrance, Redondo Beach, Chula Vista, Oxnard, Newport Beach, right? And here is Thousand Oaks. So we are higher than our regional. The Conejo Valley is more changed than our regional areas in our immediate area. And while we're not quite as high as some of these places in Wisconsin, et cetera, we are pretty close. Okay, sorry, I forgot to say. So so we're the summer highs are getting hotter. And so that picture on the upper right is one of my plumeria, my plants in the backyard. Don't water it as much as I should. What a jerk I am. And so this sucker is getting stressed because it's getting hotter and hotter. So the leaves are still coming out in this picture. Hasn't leafed out yet. He's sort of in the, oh my God, it's hot mode. We can also talk about other aspects of that temperature. We can talk about the lows. The wintertime lows are shifting. And the same basic story. Now the cities have changed, but the same picture is we have some significant changes. Up on the right here, this is my plum tree in my backyard. And the last couple of years I've gotten very poor plum set. I get some plums, but I used to get bushels and bushels. Now I get a few. One of the reasons why, maybe I'm a horrible gardener. Yes, that's correct. Okay, we got that. But also what's going on is the fact that we haven't had as many cold snaps. To have this stone fruit really set the right leaf buds and do all that stuff, it needs some colds. And we're not getting as many colds. So as a consequence, I'm not getting as many flowers, not as many fruit set in my backyard in Thousand Oaks. So when we pull this all together, this is what we look like in terms of our Conejo Valley, Thousand Oaks temperatures, typical annual weather. The gray is back in the day for the last couple decades, what the typical temperature range was over the year. The average temperatures per day, and then average those temperatures. And this is what it's going to be like in 2065. Now that might not look like a lot, like the bars are kind of shifted, but they're not like one isn't, a million times higher. That is massive in terms of animal critters, plants, everything. Let's talk about rainfall, rain. So here's Western snowpack. In this picture, the red colors indicate less snow or less precipitation. Most of this is snow. And so red is bad. Blue means more than average. And so this is a 30-year data set. And the only thing you need to know is there's lots of red around there, not a lot of blue. And what does it look like when we fly over the Sierras? If anybody, I'm not flying very much these days. I suspect most of us aren't flying that much these days. But next time you are, we would typically see a picture like on the left, where that white would be snow in the Sierras, which is where at least 1/3 of our water supply comes from for drinking and all that good stuff here in Ventura County. And this is what it looked like in 2015. And it looks it looks about that way right now, actually. It's a little teeny bit worse, but it looks probably similar. We're losing our snowpack. That's our water storage for summer, spring, fall. And so when we take all this together, this is the water risk that we see for our area. So again, we are really stressed. So Ventura County is right in this coastal plain of Southern California where we are extremely water stressed. When we look at all of our states, New Mexico, technically speaking, comes out to be more water stressed than we are, but California is pretty darn close right behind it. So we have this temperature thing's changing. The water situation is changing. And then we can combine these two things together, the hot and the moisture and the temperature. So this is, again, over 100 years of data. And we have precipitation over here, less, more. And we have temperature, cooler, hotter. And so, some years are cooler, some years are warmer, some years are wetter, some years are drier. And so they're all over the place. But pay attention to the time since 2000. And this data only goes up to 2018. I haven't plotted the last 2 years on here. But basically what you see is everything is over here. Everything is in the hotter. And when we have our most problematic wildfire times of the year, say 2018, we are in the hotter and the drier. So these things are starting to combine. So one of the reasons why we are so different is that as we start to pull all these different variables together, we're in trouble. And the news yesterday was that we have the driest January and February ever recorded in California history, this current January and February. In December, everybody's talking about, oh my God, it's so much rain, it's great. totally globally weirded, right? This is totally normal in terms of this new world that we're in. We also have things like air movement, winds. So up north, we have these katabatic winds that we call the Diablo winds. Down here, we call them the Santa Anas. Basically, it has to do with high pressure inland and some atmospheric things. A lot of colleagues have been monitoring this. These are all different fires within measurements of different individual fires. And we're trying to model this more strongly. But long story short, much more devastating fires when we have more intense Santa Ana winds. You cannot compare the fire damage to life, to property, to wildlife, et cetera, without taking into account these wind-driven fires. When it's not windy, we have relatively normal fires. Our fire crews can get out, control that, put lines around it, take control. When it's super windy, look out, right? So the embers are igniting, starting new fires, sometimes 5 miles from the fire line. Very different from a non-windy condition. And so you see these just very intense things. That was the story of the Woolsey fire, for example. That was the story of the Thomas fire, and we can go on and see all of those things. So all this stuff together combines to make this changed world that we're in right now. So my wife grew up around San Ramon. So here's up here in the San Francisco Bay Area. This is what San Ramon was like, or the average climate in San Ramon, the average weather year in, year out, a couple decades ago. And this is modeling all this stuff together for 2050. So all these cities in the US, their climate will have changed by the time you get to 2050. It's probably gonna happen before we hit 2050, but at least by 2050 to be more like the climate of these other towns. So my wife that grew up in the San Francisco Bay Area, I did too, you've seen my wife, it's that climate of that city is gonna be like a Southern California city, right? And this is going on around the planet. Okay, let's talk for a second. We're gonna talk about fires next. So let's next talk a little bit about some fire context. And so the context here is that okay, we're looking at a historic. This data happens to come from Arizona, but it's I like this figure because it really illustrates everything so nicely. But the same thing happened all around the U.S. And this is using burned tree trunks and cross sections of trees, dendrochronology, to count how old the tree is and actually look at fire scars. So when we have a scar that doesn't kill a tree, it makes it sort of charcoaly on the outside of the bark, and then the tree continues to grow, and we can see that mark, so we can record that fire. And by looking at a lot of old trees, we can essentially walk back and we can reconstruct the fire history of these different areas. And that's what we're seeing. So there's a couple things here. Probably I'm talking too long and that we're need to go faster here. But I'll just say that all you need to know is lots up here, little right here. And what we can see here, let's look at this jagged line, this line that's up, down. Some years there's lots of fires, right? So there's lots of fires going on all over this forest. Some years, not much. So some years it's up, some years it's down. There's a sort of natural up, down, but there's always this kind of up and always this kind of down. And then the particularly large fire years are noted with the numbers here, and these years happen. Key thing is notice what happens after about 1900. So it's up, down, fires, and all of a sudden, very few fires, right? That was a choice that we made. That was a policy spurred, I can talk for hours about this, but spurred by the creation of the US Forest Service and this idea that wildfires, quote unquote, waste a resource, and we want to save those fires. So we entered into our modern era of actively suppressing wildfires. We're not talking about cities now, we're talking about our grasslands, our woodlands, our forests. And so in most cases, we've reduced the amount of ignition that historically happened. And so as a consequence, we've allowed all these fuels to build up. That's the story in most of the US. Right here in the Santa Monica Mountains in our area, a little bit different. Here we actually are seeing increased rates of fire. Increased rates of fire because we are so innervated. We have so many developments, so many houses, et cetera, in the wildlands urban interface in this transition zone. And we're actually seeing more fire than we would historically predict. So for our area of Conejo Valley, Santa Monica Mountains, this area, something like 20 years or so would be a typical fire return rate. Meaning if we had a fire, a natural occurring wildfire, say from a lightning strike, we would something on the order of a couple decades, 20 years, let's call it, when we'd see another fire. Some of our areas in our greater region here, we're seeing fires every 7 years, right? Return, which is crazy, absolutely crazy. So this is again a choice that we've made because of how we've chosen to develop and how we've chosen to put our houses and our infrastructure. Yeah, I'll just say that there's some stuff about wildlands urban interface. Okay, when this all comes together, all this stuff produces dangerous fire weather. We have, and especially when all these things come together, when we have hot temperatures, we have a dry year, and when our winds start blowing, and we get we see these warnings, right? And so this is the situation, for example, right before the Thomas Fire, for example. Everybody was like, "Oh my God, danger, danger, danger!" This is a wind field map, and everything was super windy, and particularly windy right around the Conejo Valley, right? So we are often epicenter for these crazy winds. The Oxnard Plains and we tend to be big players in this wind danger, and it can massively transform our landscape. I won't spend much time on this because we all know about this, but one quick image here. This is the day before the Thomas Fire erupted. This is a nighttime image from a satellite that senses just light. So it looks like we've mapped roads and things of that nature. This is we've outlined some of the islands and stuff, but most of what you're seeing is simply light pollution, light from cities, from the greater Los Angeles metroplex, right? So this is when the Thomas Fire starts. So the Thomas Fire becomes of the same magnitude in terms of light pollution, in terms of intensity, as urban Los Angeles. Crazy, crazy intensity in terms of these fires. I also just want to note that, again, fire is a natural part of our system. We need to bring fire back. Climate change has been exacerbated in terms of fire by the fact that we've not allowed natural fires to burn. But here's where the Thomas Fire was, for example. And you see the perimeter goes right up to where these other historic fires were. So having fire can be a useful tool to minimize some of the worst parts of climate change, at least climate change-induced fires. Yeah, I'll say that. Let's talk real quickly about some of the effects on critters that we see with fires, particularly these wind-driven, climate change-intensified fires. And so this is some data from a monitoring effort I was doing right before, just randomly. It sounded like I'm an arson or something. It sounded like I did this monitoring right before the fire happened. Then the fire happened. I had before and after data, but this was just a class that I do on one of our pieces of land at California State University Channel Island. So this is the fire starts on the Conejo Grade at about a little before 7 o'clock in the morning. By 10 o'clock, campus was evacuated, and essentially all of campus was burning. The only reason why campus exists is because we had 600 firefighters that ran to campus and kept the buildings from being completely burned up. But our natural landscapes all burned up. So we went from looking like places like this to places that look like this in a couple hours. And we've all seen similar things of this: Hill Fire, Woolsey Fire, etc. So I'll just talk about what happened with the critters, with the animals here. And what I'm showing you is we have camera traps out and we're taking pictures of animals. So we're measuring how many animals are coming by an area. All you need to know here is this is low and this is high. No animals or very few animals, and lots of animals. And we have some different areas here. This is next to our creek. So this is a water source. And as we go to the right, these are sites that are farther away from the water. Animals like to drink water. And so this was some previous data back in the day. Here's some other previous data. This is back in the day. So kind of low level. The critters are around here. They're at this sort of background rate. And then right before the fire, again, I'm not an arson, don't sue me. Right before we're doing that, and this is what was the condition, then boom, the fire happens. And within actually about 3 days, we had new cameras out there. And all of a sudden, way more animals. Tons of animals. They all freaked out and ran to the water. So we act as an aggregator and sucked in all these animals that were normally spread all across the landscape. Now they're all concentrated and freaked out. There was no place for them to hide. There was no place for no shrubs for the rabbits to hide under, et cetera, et cetera. This continued for a little while in June 13, and then would decay back to more of a normal situation when the vegetation recovers. But the important thing is this didn't affect all animals equally. And so with all these aspects of climate change, there will always be some winners and there will always be some losers. But unfortunately, there tends to be way more losers on average than winners. But in the case of these critters, what we found is that it mattered the size of the animals. The large-bodied animals, the deer, for example, they could run away from the flames. Not everyone, but many of them could. And so in the case of the Springs Fire, they ran out of the Conejo Valley, they ran out of these areas and they ran into the Oxnard Plain and places like that. Small and medium guys kind of did the same thing. Small guys couldn't. Small critters stayed and essentially burned up. So again, our big thing survived. So our coyotes, our bobcats, our mountain lions, our deer were by and large okay. And again, these are all pictures right after this fire, or within about a week or so of this fire. But our small guys died. So our baby coyotes died. Our rabbits burned up. And so this is we can now use this to predict what's going on with these critters and who's going to be most harmed, etc. Okay, love to answer all those. I can answer questions about animals and wildfire forever, but I need to get on and wrap this thing up. All this stuff together is making for many more costly disasters. So in this case, these are the number of at least $1 billion events in the U.S. Each year, accumulated over the course of each year. And so each color represents a different year. And have a look. We start out kind of low in this background level, but as we get more closer to, I didn't put 2021 data in here yet, but as we get closer and closer, it gets more and more. So 2020 is crazy high. And we have some years that are quite outliers. So things like 2017, things like the Thomas fire in those years, when we have things like these very devastating, massive scale fires across the US. Not only are we having lots of these events, we're having more and more costly events in aggregate. So I want to make sure I leave plenty of time for questions. What do we do with all this? So, oh my God, the animals are getting hurt and it's getting hotter and our plants are having problems growing and all this and that, and there's endangered this and that. What do we do? What do we do? It can be very easy to get depressed over this kind of stuff, right? Oh my God, my students say, oh my God, Dr. Ray always depresses us. But let's not be depressed. Let's not be depressed. There are signs of hope, but we need to engage. So a couple things here. These are 4 things you guys can do. First, and we'll go through each of these. First, smile and don't despair. So be positive. There are reasons to be positive. Secondly, we need to decarbonize our energy systems. Number 3, we need to make our built landscapes, our built environments more resilient to these stressors that we can see are coming more frequently and more intensively. And then next, we need to make our natural systems also more resilient where we can. So let's start with the first one. Let's smile and don't despair. I'm not Pollyanna-ish about this, but I am bald. I'm kind of sort of an old dude. I am an old dude. Yeah, it's true. I'm an old dude. But so I've had a little bit of life experience. And so I want to share a little bit of that with you. So when I was young and growing up during the Cold War, I was absolutely convinced that the world was over. I was absolutely convinced. And so this, maybe some of you saw this made for television film, The Day After. Incredibly depressing. So this show was about a nuclear war with the Soviet, what we then called the Soviet Union, and focused on people, right? So it wasn't like shoot 'em up war. It was what would happen after this event, and it was so realistically portrayed that we actually had crisis counselors on 800 lines so that people could call in from across the U.S. because it was so scary. So this is what I grew up in, right? I grew in this era thinking that it was highly likely that Cuban Missile Crisis, somebody's going to screw up something and we were going to die in a nuclear holocaust. And people like Carl Sagan and others that try to warn us of this would have these meetings and have these debates, and they'd say things like, imagine a room awash in gasoline. There's 2 implacable enemies, and each one of them has 9,000 matches, the other has 7,000 matches. And we're betting who's stronger, right? So this was all very scary stuff and very worrying stuff. But at least so far, we haven't died in a nuclear holocaust, right? We changed, right? So this crazy guy over here, Ronald Reagan, who called the Soviet Union the evil empire. This guy over here on the right, Gorbachev, Mikhail Gorbachev, got together and they said, maybe we could do something differently, right? There was plenty of reason to distrust, plenty of reason to think this wouldn't work, plenty of reason to think the other side thought we were the embodiment of everything possibly evil on the planet, so on and so forth. And we made it through that crazy time. We're still living with the consequence of that in Ukraine right now. We've not solved this problem, but we got to a better place. Right. And so I was lucky enough to have lunch one time with Pavel, Gorbachev's translator. And I couldn't even talk to him because I was so emotional. I was crying, saying like, I want you to tell Gorbachev that I really appreciate the fact that he was part of taking us back from the brink, right? So we have had these periods in our history. World War II, the Cold War, dealing with the ozone layer, all these things. It is possible, even when it looks totally, totally depressing and totally, totally scary, we do have lots of precedents for us coming back to the brink and choosing a more rational path. The other thing we need to do, though, in doing this, is we need to reject the baloney. We truly do. So what's going on in Ukraine with the crazy head of Russia right now, with Putin saying things like, well, Kiev was always part of Russia. Baloney. That's ridiculous. And so this is a meme that's going around social media right now. So this is Kiev in 996. That's Moscow in 996. This is this cathedral that was built in 1011, and so on and so forth. So this notion that someone would say, oh, we've owned you forever, and that's the fact. No, right? So with a lot of the climate change stuff, there's a lot of misinformation out there. And you need to be confident enough that when someone says something silly, you push back on them, right? We cannot allow this silly stuff to keep sidetracking us from the true mission that we need to be on. Let's talk about some of the political side of this right now. So this was in the wake of the Paradise Fire, the deadliest fire in California history. And President Trump came. This was right when we were transitioning between our governors. So we had our existing governor Brown there, and our not yet but incoming governor Gavin Newsom there, and they were trying to have a dialogue about what was going on. President Trump came to tour the disaster area. And there's all this stuff that grew up. But here's an important thing. So we have to call baloney when it's baloney, right? So this is a very short clip, but this is at an airport in Sacramento where our state fire officials are trying to have a conversation with the then president.
Perspective, there is amazing partnership on the ground, and there needs to be. As the governor said, we've had temperatures explode this summer. You may have learned that we broke a world record in the Death Valley, 130 degrees, but even in greater LA, 120 plus degrees. And we're seeing this warming trend make our summers warmer, but also our winters warmer as well. So I think one area of mutual agreement and priority is vegetation management. But I think we want to work with you to really recognize the changing climate and what it means to our forests, and actually work together with that science. That science is going to be key, because if we ignore that science and sort of put our head in the sand and think it's all about vegetation management, we're not going to succeed together protecting Californians.
Okay, it'll start getting cooler. You just watch.
I wish science agreed with you.
Well, I don't think science knows, actually. Tom?
So that's not true, right? We do know. We do understand what's going on, right? And we want to have respectful dialogue and everything, but when people say things that are just factually not true, we need to say that is just simply not true. Okay. The other thing is, sometimes this can seem like a highly politicized topic. It is not. Let me say that again. Climate change is not a politicized topic. Amongst the halls of Congress or something, it might be, but you get a very incorrect impression of our state, our country, the world, et cetera, when you just look at people screaming at each other. My students have been doing surveys for the last 15 years of people in Santa Barbara, Ventura, and Los Angeles counties. Don't need to go in the specifics. Long story short, though, is to say, we've asked questions, all kinds of questions about climate change. We could be here all day if I showed you all our climate change data. But suffice it to say, let's talk about some of these disasters, some of these wildfires we've had here in our area. And so we asked people, hey, do you think that climate change played a role? It didn't say it didn't necessarily cause it, and it was 100%, but did it play a role in these disasters? And 13% of people said, yeah, no. 72% of the public say, yeah. If we ask people, are they impacted? Are they personally impacted by these events? I only have the 2018 and 2019 data here. The same thing continues on the last 2 years. But again, of a large fraction of people are impacted initially and for years to come from these events. So that's the reality. People get it. We might not agree on exactly, are we going down this path A or path B in terms of how we do this? But the notion that oh my God, we can't do anything with climate change because people don't agree. The vast majority of people agreed, and they've agreed for a long time. That's the reality. Okay, next, almost ready for questions here. So next, other things we can do. We can work on decarbonizing our energy systems. So the first one is sort of a philosophical thing. The second thing is a sort of bigger picture in terms of public policy and things. But there's all kinds of stuff we can do, right? So on the right is an editorial from a recent op-ed in the Los Angeles Times. This was yesterday or today, I can't remember, one or the other, about changing our energy systems. On the left, our own County Board of Supervisors have moved some measures, and we have a couple measures coming up in this in our upcoming election about things that relate to oil drilling, right? So you can be engaged in those debates. We need everybody to be engaged in those debates, and participate, vote, express your opinion. So that's a big picture. But let's talk more about our own local efforts here in the Conejo Valley. What can we do here? So we can work on being more resilient ourselves. We are in an incredible place here. So I was asking Tanya yesterday, I have not checked the last couple years, but I think for towns of 100,000 or more, I think Thousand Oaks, our area, this chunk of the Conejo Valley, is number 2 in the nation for the amount of green space we have within city limits, city jurisdiction. I think only Boulder, Colorado has more. So that's a great resource. So we have all kinds of things we can work on. We're a very, fortunately, we're a very, relatively speaking, affluent community compared to many communities that are trying to grapple with climate change. We can help to make ourselves more resilient. A lot of these steps that we're talking about here have all kinds of ancillary benefits as well. So it's not just going to help with climate change, it's going to help with home value, resale of our homes, all these kinds of things. So this is a giant new solar farm that we put in on our campus at Cal State Channel Islands. It turned on for the very first time on December 21st. And this is we can do these large scale installations, but we can do other things other than these big, massive projects. These are great, but we can also do so-called microgrids. So this would be where we have our apartment complex, our townhomes, our HOA, our development. We can work on solarizing our roofs, for example, and we can have our grid. We can create a microgrid, right? So this is totally possible. People are beginning to do this around the country, so that we're not necessarily reliant all the time on the big giant grid. That's also, by the way, the thing that causes public safety power shutoffs and causes all kinds of other issues. Then we lose power when it gets windy and all this and that. So we can engage with our HOAs. We can engage with our neighbors. And so if we're looking here at a classic, development here in the Conejo Valley, I see right here a little bit of solar on this person's roof right here, maybe a little bit of solar on this person's roof here, and a little bit here. But by and large, these are empty roofs. This is a missed opportunity, right? Installing these types of systems can, again, all the data shows it more than pays for itself in terms of home resale value. It pays for itself in the less stress you have during the fire season, because you have power. You don't have to empty your refrigerator when the public safety power shuts down other folks. And by making our neighborhoods more resilient with microgrids and the like, we're actually helping to relieve the pressure for our fellow citizens, or other folks that don't have the resources to install some of these microgrids. So that's one example of many we could talk about to make our built environment more sustainable and more climate friendly. Then we can talk about our natural systems. There's a million things. So the Conejo Open Space Foundation does all kinds of fantastic stuff. COSF, all of our wonderful agencies have all kinds of opportunities to be involved. As we restore our native communities, as we make these systems more healthy, connect more wildlife crossings and bridges of that nature, we're making these systems more able to respond to climate change. So if we have, for example, with our wildlife crossings, if these critters can more easily get from this side of the road to over here, in those days when that area might be water stressed, they might be able to get over to another water source and persist. If they don't have that, they're going to run onto the road and become roadkill, or they're just going to perish. So there's all kinds of opportunities. One quick one that's coming up in a couple days here is our second Monarch and Milkweed Conference. Free thing to attend. You guys can attend. You can get free milkweed seeds, which is the food plant, the plant where our monarchs need to have to be able to forage. Fantastic thing to do. right? So you can be involved. This is something little kids can be involved with. This is something old folks can be involved with. Even college professors can be involved in this kind of stuff. So, so it's great stuff. And this is but one example of a million opportunities we have around here. Our national parks system, our state park system, our local parks, all kinds of wonderful opportunities. Get out there and get involved and get your hands dirty. Again, don't despair. We need to decarbonize our systems. That's a bit of a bigger thing than we do individually, but you can lend your support to that. But individually, we can work on making our homes and our own infrastructure more resilient. And we can work on making these natural systems more resilient. And then lastly, self-care, right? In these crazy, scary times when we're hearing about what's going on in Ukraine, what's going on with COVID, what's going on with climate change, it can be easy to get depressed. Do not get depressed. Smile, right? We need to have this self-care. It's a really, really important thing so that we can have our soul's batteries be charged up for grappling with these changes. And with that, we'll stop there and take whatever questions you guys you might have drummed up for me, and I will attempt to answer them. So thanks, everybody.
Wonderful, Sean. And my gosh, fantastic information and so much for all of us to think about. You know, I have to share real quickly that I do have the opportunity to fly over the Sierras from time to time. I have a wonderful fiance who is a pilot. And I can tell you that is the best way to see climate change. I see the snowpack levels. You can see the damage from the fires. It's really quite impressive when you see it from the sky. But Sean, before we jump into their questions, I'm going to be selfish and ask you a question myself. You know, I do appreciate the signs of hope if we engage, and I love that. I love how you talked about, you know, 2050 really sort of where we will see some significant changes, if not before. What do you think Thousand Oaks might look like in our future if we don't continue to do some more resilient activities? What will you envision we might see as changes on our trails?
Much more brittle vegetation, so less lush flowers and sort of fleshy plants, not as many of them. We'll see more of the annual grasses, so the non-native annual grasses will definitely spread. And it's ironic. One of the, ironic, I don't know if that's right. It's when we think about things like oak woodlands, right? Sometimes we think, oh my gosh, those are really fire prone, right? Those are really dangerous. And of course, oak trees can totally burn up, right? Yes, they can. But most oak trees with relatively small fires, oak trees, maybe a little seedling would burn up in a fire, but an adult tree would get a little singed and then keep growing. So it's really one of our most dangerous fuel types are these annual grasses, these very flashy fuels that grow and then die back and create essentially all this kindling that's just waiting there to get caught. And so we're going to see a lot more of that around all of our trails and our open spaces. We'll see things like laurel sumac, our sort of classic shrub tree kind of thing. Those critters, those plants can persist for, we have some of our colleagues from Pepperdine University have had individuals marked and can pretty reliably, if had them cored, know that these trees have been around for some of them hundreds of years. They get burned a little bit and then they resprout. But we're starting to see signs that some of those trees or some of those shrubs that have burned and resprouted for decades and decades, if not centuries and centuries, some of those are starting to die now because the drought is becoming so intense. So we're going to see less cover, less shade, because that woody vegetation is going to become, well, it won't go away. It's not as if there's going to be no trees or something, but they're going to be less abundant. And so we'll see more of a kind of grassy golden look when we look in the hills and less of a sort of dark green shrubby kind of look, if that makes sense.
Yeah, absolutely. Thank you for sharing that. And I will still keep smiling, I promise.
Okay.
Well, now we'd love to hear from all of you. Thank you all for joining in. It looks like we do have some questions in our queue. Marcella. And if please, as we're talking here, feel free to ask more questions. Throw them in the Q&A, please, not the chat. Feel free to pop them up and we'll keep an eye. Marcella, would you like to ask Dr. Anderson some of the questions from the queue?
Sure. And because we have a lot that are similar, I'm going to aggregate some of them, but some of them I will read specifically because I can't aggregate it. So, all right, let's start at the bottom here. What are the specific drivers for the rapid change in areas like Thousand Oaks and St. Louis? You showed several slides that led one to suspect that wind patterns might have to do with the Thousand Oaks area.
Yeah.
Is this a big component? Do the areas with the highest degree of change have similar characteristics?
Not necessarily. I would say the thing that they have in common is a confluence. So in our case, absolutely correct. In our case, we have these canyons that are bringing this sort of that are really do a really good job of funneling inland air masses to the coast to us. And so that's why, we're particularly bad as opposed to San Luis Obispo or, another coastal place. But I would say the thing that unites these places that are the most problematic or the most changing is local geography and local circumstance such that these things can all combine. So it's not just the winds. In our case, it's the winds. If we're talking about Minnesota and those places, it's not so much winds, but there it has to do with their how they respond to or where they're located with regards to the jet stream. So it's a unique confluence of these things. We couldn't have maybe some people could, but I couldn't have predicted that these individual places, a priori would have been the worst. But once we start to look at the data, we can understand why. But it absolutely is the case that we in Ventura County are so on the precipice because of the Santa Anas. We would be problematic even without the Santa Anas, but the Santa Anas takes us to that craziest time that we dry out so much faster than our other areas that don't have those kinds of very intense winds.
Okay, Anne asks, I'm wondering, what is the role of climate change in the development of pandemics in 30 seconds or less?
Huge. So first and foremost, we were seeing, just like we're seeing shifts of critters, and we're also seeing shifts of disease. So the classic one everybody talks about would be mosquitoes, so vector-borne diseases. So, for example, I'm in a week and a half or so, I'll be taking my students to Louisiana. I take my students to Louisiana every year since Hurricane Katrina, except for the 2 years of the pandemic. And starting a couple of years ago, we had to start having to worry about Zika and some of these other viruses that wouldn't have existed here before. So as we have these crazier conditions, just like we're making things better for weeds, we're also making things better for many of the insects and other critters that spread disease. So, for example, we had the crazy dumping of rain in January, and then we got this really warm period, right? Dry period. Perfect to have little standing pools of water or little areas of water where you can have these mosquitoes grow and then they could spread, especially Aedes aegypti. So hugely important in terms of providing the conditions where stuff can spread. And then lastly, I'll say, I'm talking more than 30 seconds, so I'm in professor mode here. The other thing is critters are stressed. So when we're stressed, our immune systems don't work as well, whether we're talking about a fungal disease, a microbial, a bacterial disease, or a viral response. We are less able to fight it off. And so one, we're having more exposure to the things that might cause the disease. And then two, we're having our systems be stressed. And then I guess the last thing would be as critters are more stressed and they're dispersing into new areas, that is another opportunity, particularly with things like birds, and particularly with things like civets and some of the mammals and other. I'll just say that. I'll talk for hours if I talk about all that stuff. But basically, the mixing of things make more opportunities to happen. Stress makes you more likely to get it, and the environmental conditions can create the opportunities for more of the vectors to do well.
So didn't you tell us to smile?
I am smiling.
After that answer.
I smiled when I said that. I smiled when I said that.
He smiles as he tells us the bad news, right?
Yeah, right. Yeah, there are definitely more mosquitoes than we've ever seen. That's for sure. Okay, so do you see our coast live oak woodlands becoming type converted to more fire-prone species?
That's a great question. I'm very interested in that. So that's a real good question. That's a fantastic question. So one of the biggest problems we saw so we're probably in this, so the term drought is probably a misnomer now because we're just in this other period, and this period just doesn't have, drought is sort of deviation from normal. But now we're getting to the point where there just isn't ever a lot of water. But our last quote unquote drought, the last round a few years ago, when we were in that period, and some of the restoration groups I work with work on oak woodlands and other woodland restoration projects. We had to radically change how we were doing outplantings of new baby oaks, of acorns and seedlings and stuff, because historically we might plant an acorn and water it in a little bit and do a little bit of watering or water for a short period of time, and then it would be okay. Now it was all we could do to constantly be watering these things, and even then there was a very high mortality of these individuals. So the existing stands are probably okay, but we're very concerned with the recruitment, so the next generations coming in behind them, and so that's a huge concern. I mentioned I was going to New Orleans. One of the things that's gone on there as a result of Hurricane Katrina, and one of the main things we're working on, is trying to prevent a type conversion of those forests, bottomland hardwood forests. In this case, it's swamp. It's wetter, but it's the same basic idea. The system was stressed, and then when we had this climate event, in that case it's a hurricane. For us, it would be a big wildfire. When it gets stressed, the system can't recover at the same rate. With a lot of our oak trees, the acorn set is related to the rainfall 2 years ago. So if we have a really good rain year, you might think, oh, we're gonna get tons of acorns this year. Not necessarily. You tend to get a lot of good acorns the next year. And so these in the period where we came out of, that wasn't a huge problem, right? Because we were like, oh, some years are dry, some years are wet, but that's fine. But now as we're going into these periods where we're having very extensive dry periods, we might really see close to, at least in some areas and sometimes, maybe complete reproductive failure of these oaks. And it only takes one fire or one guy driving off the road with his car and smacking into a trunk to sort of take out that adult, if we don't have the next generation coming right up behind it. So that is a concern. I can't say that's absolutely going to happen, but that is a strong worry.
Okay, we have a lot of questions here about what, and again, we could talk all night on this. If you were to plant a tree to be around for a couple hundred years in the Conejo Valley, what species would you plant? And then secondarily, I'm going to aggregate a few here. For local companies, what are some things that you would suggest local companies do to promote or implement, especially because a lot of the companies around here pay their employees to volunteer? What are some things that you would suggest they do?
Oh, great question. Okay, so first let's talk about what tree would I plant? Oh man, good question. Good question. So I guess just a generic Conejo Valley question. It's going to depend if we're in like a little draw or whatever, but I would say probably an oak. You could go with Coast Live. You could go with like a blue or a valley oak or something like that. But I would say probably an oak tree, not knowing the exact aspect of the hill slope and that kind of stuff. But that's, I think, a safe bet. As far as other things, if you wanted a woody thing that maybe wasn't a quote unquote tree, you could do some of our more chaparral species, some like manzanitas and things of that nature. But yeah, I would go oak would be my again, another thing that take a long conversation, many beers to get into it specifically, but I would say that. The next was what can let's see, what can companies do or what can businesses do in terms of making a change or a difference? And I would say volunteering is awesome, but I think getting out ahead of the climate change stressors for your business in and of itself would be a fantastic thing. So one quick example, I was some folks from Amgen were talking to me, I don't know, a couple months ago or whatever, and they were needing some context and some water efficiency stuff that they were working on to reduce their water usage. And brilliant idea, right? So they were going to be reducing their water usage, which was going to reduce their water and their power. And so that sounds like an environmental thing, and that's great, and that's sort of helping us be more sustainable. But it's also helping their bottom line, right? And they're doing that stuff now. All these things that your business utilize, we all use power, we all use electricity, right? We all use water, at least if at least in our bathrooms or sinks or something of that nature. I think it's really behooves all of us to get out as far and as soon as we can in front of these things. So right now, things are gettable, right? If history is any kind of guide, once we have a crisis, it's going to be a lot harder to do that. So once we get a couple more years into this current drought period, it's going to be it's going to be hard to get some of the stuff. There's going to be a waiting line to get some of these more water efficient faucets and the like, and things of that nature. And now is the time you want to get in and get that done. What we've seen, and yeah, I get dark. I can talk about what I think will be the triggers for some major sociological changes, but my friends that stocked up on blue tarps in Louisiana before, their roofs are okay right now. We had this massive Hurricane Ida came through this past summer. One of our friends, their son just moved out of their house. He was living with them for 9 months, 10 months, because his house, he couldn't move. His house was unoccupiable because he didn't have any blue tarps. And when Ida hit, there was such demand, no one could get that equipment. And so once we get to these crisis points, the solutions or the things we might need with energy, with water, with other resources, other infrastructure things will be hard to come by. So you would all, I think, benefit your companies by getting out in front of that now. And so that'd be one thing. As far as like, where can we volunteer? What can we do? One great thing that's coming along, I'll just do a plug. So I have to say that I'm an elected or appointed member on a lot of different boards or agencies, one of which is the Ventura County Resource Conservation District, full disclosure. And we just recently secured a grant from a CAL FIRE to start the first of its kind, at least in Southern California, Fire Academy. And so this is a fire academy that's designed for the private citizen. This is not a fire academy for county firefighters or city firefighters. This is for private property owners that want to have more controlled burns on their property. Obviously, that's not to start out with. That's not a suburban lawn owner, but for folks that might have a commercial property, for people that might have ranch land, ag land, stuff of that nature. It's very hard to do our controlled burns. I went to 19 controlled burns when I was up at Stanford University before we moved down to help start this university. 19 controlled burns before I got to go to my first controlled burn. They were all called off at the last minute because of air quality concerns. So then as a consequence, we don't burn as much. And then we have these massive wildfires that turn San Francisco into Blade Runner, right? Orange skies for 3 weeks. And I guarantee that's worse for people's asthma and breathing. But with this new fire academy, which will be starting up this fall, the idea is private citizens can come and learn how this stuff works. And not only are we working to have sort of safe burn practices, we'll also have people that are trained and know how to properly do fires that will be in charge of doing some of these fires. And we're trying to have indigenous traditional knowledge in there and all this kind of great stuff. The point being, we're trying to create an area here in Ventura County where we use fire as a frequent management tool. When we say controlled burns, we're not talking about 1 million acres burning. We're talking about, let's burn 10 acres here. Let's burn 5 acres over there, right? That's the kind of scale that we need to get back to this safer area, reduce those fuels, better for nature, better for the fire risk. And that kind of stuff can protect our businesses, protect our homes, et cetera. And so having a place where the general public can interface, take classes, learn about this stuff, way better, right? Way better than having some county agency come in and say, oh, it's going to cost a gazillion $1 million to do this, and you need to pay all this liability and that. So I would say, so keep your eyes open for this fall when our fire academy starts, and there will be concomitant lots of opportunities there. And then the other one I would just say is check out I would just search Santa Monica Mountains and restoration. There's the MRCA, there's the Santa Monica Mountains RCD, there's all kinds of fantastic organizations, consulting firms, as well as Joint Powers Authority and government agencies or quasi-government agencies that are doing activities almost every weekend in our area. And so fantastic way to do bonding and get everybody dirty. One of the things that I've found, I've been doing restorations for decades, is it's great to clean up and do garbage pickup and everything. Those kind of stuff are wonderful. But planting a tree, planting a plant, especially with your coworkers or your kids or your parents, and being able to watch that long live plant be there and then be there the next year, it really gives ownership to that land, right? And people really do have a much more intimate stake, and like, you know what, I really want to make sure that this area stays protected. And so I would say, so those types of opportunities all the time going on.
So I would say, I mean, we do have a few other questions, but they're wonderful questions, but they are very, very, I mean, it would take you probably a couple hours to get into those. And so unfortunately, I don't think we're going to get it. And I think we've run out of time, haven't we, Tanya?
I talked too long? I talked too long?
No.
Oh, okay.
We have about 3 more minutes if you want to try and squeeze in one more, or we can wrap it up.
So I would, again, we do have a lot of water. So a number of people are saying, what can we do to become a little more water resilient here in the Conejo Valley? We've got 4 or 5 questions like that.
Okay, great. So that question is like homeowner kind of question, or is that more kind of like public policy kind of bigger?
They're talking homeowner.
Okay. So there's a couple different, there's very, first and foremost, get rid of your lawn. I have some friends that own sod. I'm sorry if they're listening, but get rid of your lawn. It's bizarre. There's a whole bizarre story as to why we have lawns in the United States, but it was this effort to emulate what was going on in France and England and stuff for silly reasons. They really don't belong here. Use way too much water and don't provide those biodiversity benefits. If you have some kids that are playing soccer, they're great. By all means, have a lawn. They're fantastic for that kind of stuff. But short of that, you should be pulling out that lawn, putting in native plants, drought tolerant, but native drought tolerant, not just. Sometimes when you go to the say the Home Depots or the Lowe's of the world, some of their plants might be listed as drought tolerant, but they might be from South Africa, it might be from Australia, something of that nature. So California native. Check out our local native plant nurseries here in the Oxnard Plain, in Thousand Oaks, in the San Fernando Valley. That's a great place to go shop and get plants. So I'd say first and foremost, get rid of the lawn and put in drought tolerant plants. Number 2 would be to consider gray water systems. So it is a little bit crazy that we water our, say, trees and our plants with potable water, right? I want to give our dogs potable water. I want to drink potable water, but we don't necessarily need all that for our oak trees, for our sedges and things of that nature. So one thing some folks can do, if you're so inclined this way, it takes a little bit of plumbing notice, but a little bit of plumbing know-how, but you can do a gray water system where, for example, your laundry, instead of which, we don't want to do this with our toilet water, right? But with our stuff like, say, our washing machine waste, that can be plumbed out and can be put in the garden. Right. I do a lot of work with microplastics, which is a whole nother topic, whole nother subject. And so there are some issues possibly with some microplastics, but by and large, That's a source, right? How many loads of laundry do we do every day? I have an outdoor shower at my house. Maybe that's revealing too much, but I have an outdoor shower. So when I use that shower, it just goes out, and that water just waters my plum tree and pear tree and the stuff right around where my shower is. So I'm not, pouring baking grease down in there or anything of that nature, but things of that nature. Can we use the water twice? Another one you can use is a circulating pump, right? So that not so much in the summertime, I don't know if we need it so much, but in the wintertime when it used to be cold, right? Sometimes people would you might want a warm shower or whatever, and you might turn the water, it might run for a while. So one option is to have a circulating pump, not going 24 hours a day, but only, so mine, I flick on just, for a minute or two before I turn the shower on, and then I have on-demand water, and it's warm, and I'm not wasting any water. If you don't have a pump, you could use buckets in the shower, right? And so put a bucket in there and then turn the water on. That gets a little labor intensive, and if you ever trip one day and spill it over the floor, you'll be very angry with me. So that's only for the young bucks that have big, strong shoulders and backs to do that. But I'd say those types of things are really great.
All right, and the rest of the questions are ridiculously specific and awesome questions, but I do think we'd be getting way off topic on kind of the remainder. And people are asking if there is going to be a recording, as Tanya indicated. We are recording this, and this should be up in about a week on our website. So
awesome.
Great. And we will let everybody know when it's up. So look in your email inboxes, and we'll let you know there. Sean, thank you so much for walking us through some of these questions. There was so many great takeaways here. I really appreciate the insight, and you really have me thinking. So I hope
awesome.
The rest of the audience is doing the same. Marcella, thank you for ushering us through the many thoughtful questions. I appreciate your partnership. And many thanks to each of you for your participation and for the wonderful questions. Sean, thank you for working with us tonight and for sharing so many insights. We appreciate the value, appreciate and value all the great work that you do, not just for us, but every day for so many people, and especially how you find the time to educate, inspire all of us for the betterment of our natural spaces. And we truly thank you. We hope that you'll stay engaged with us as COSF in the future. And on behalf of the entire board and all the participants, thank you so much for tonight.
Thanks for the invitation. Thanks, everybody. This was great. Thank you.
Well, our event has come to an end. I know I have a lot of takeaways from tonight. I hope you do as well. If nothing else, I hope this webinar gave you the opportunity to stop and think about your role in taking care of our outdoor spaces. To each of you, while we deal with a chaotic world, I encourage you to go forth and hike, bike, and ride those horses. Enjoy our Conejo Valley, and please continue to be partners with us in the months to come. Thank you for your donations, your volunteerism, and for your participation. I'll see each of you out on the trails, and until next time, good night.
Bye, everybody.